In a three-phase, three-wire system, a neutral wire is not typically a standard requirement. However, there are several legitimate reasons why someone might include a neutral wire in such a system. Firstly, future expansion considerations might be a factor. The electrical system may be specifically designed to accommodate the potential addition of single-phase loads or even three-phase, four-wire loads at some point in the future. In this case, the neutral wire is essential because it provides a dedicated return path for the current flowing in those single-phase circuits or the anticipated four-wire circuits. Without the neutral wire, these types of loads wouldn't function correctly within the three-phase system. Secondly, the neutral wire can play a role in grounding. Although it is not its primary function, it can be utilized as a grounding conductor. This means it provides a low impedance path to ground, which is crucial for safely conducting fault currents and mitigating other electrical disturbances. This grounding capability helps to protect equipment and personnel from potential electrical hazards. Thirdly, the neutral wire is sometimes required to power control circuits or other auxiliary devices. These devices often need a stable reference to ground for their operation. The neutral wire provides this necessary reference, ensuring that these control circuits and auxiliary devices function as designed. For example, a motor starter might use a 120 volts control circuit derived from one phase and the neutral. Fourthly, in some specialized cases, the neutral wire might be utilized for communication purposes. Certain communication systems are designed to use the neutral wire as a communication channel. This is a less common application, but it can be a valid reason for including a neutral wire in a three-phase, three-wire system. Fifthly, the neutral wire can be beneficial for testing and maintenance procedures. It provides a convenient point for technicians to check voltage levels, perform continuity tests, and diagnose any potential issues within the electrical system. Having a neutral wire available simplifies these tasks and makes troubleshooting more efficient. For instance, one could measure the voltage from each phase to neutral to help determine if a phase is missing. It is also worth considering the possibility of human error. There is always the chance that an electrician or installer simply made a mistake and included the neutral wire unnecessarily. While this is less likely if the installation was done by a qualified professional, it is still a possibility that should be considered, especially if there is no other clear reason for the neutral wire to be present. To definitively determine why the neutral wire is included, you would need more specific information about the overall electrical system, the intended use of the equipment it powers, and any relevant design specifications or documentation. Without this additional context, it is difficult to say with absolute certainty why the neutral wire is present. In electrical systems, conductors are identified by colors. According to the National Electrical Code, or NEC, a grounded conductor, commonly referred to as a neutral conductor, must be identified by the color white or gray. The green wire is typically reserved for grounding purposes only. The colors brown, orange, and yellow are often used to identify the ungrounded, or hot, conductors in a three-phase system. The NEC provides specific guidelines for conductor identification in Article 200. It is important to adhere to these guidelines to ensure safety and prevent confusion during installation and maintenance. The NEC also outlines the requirements for grounding and bonding in Article 250. This article covers the proper methods for grounding electrical systems and equipment to minimize the risk of electrical shock and fire hazards. Grounding is a critical safety measure in electrical systems. It provides a low impedance path for fault currents to flow back to the source, which allows protective devices, such as circuit breakers and fuses, to quickly trip and de-energize the circuit. This helps to prevent electrical shock, equipment damage, and fire. Bonding is another important aspect of electrical safety. It involves connecting all metal parts of an electrical system together to create a common ground potential. This helps to minimize the risk of electrical shock by ensuring that there are no voltage differences between different metal parts. Control circuits are often used to control the operation of electrical equipment, such as motors, lights, and heating systems. These circuits typically use low voltage power, such as 24 volts or 120 volts, to operate relays, contactors, and other control devices. The neutral wire provides a return path for the current in these control circuits. Testing and maintenance are essential for ensuring the safe and reliable operation of electrical systems. Regular testing can help to identify potential problems before they become serious. Maintenance tasks, such as tightening connections and cleaning equipment, can help to prevent failures and extend the lifespan of electrical equipment. The NEC provides guidelines for testing and maintenance in Article 100. Without a neutral, some single-phase loads couldn't be connected between a phase and neutral to obtain the required voltage. If the system is intended to supply both three-phase and single-phase loads in the future, running a neutral along with the phase conductors during the initial installation can save time and money compared to adding it later. If the neutral wire is used as an equipment grounding conductor, it must be properly sized according to NEC Table 250.122, based on the size of the overcurrent protection device protecting the circuit. The neutral wire must also be connected to the grounding electrode system at the service entrance. Even if a neutral isn't strictly necessary for the current load, its presence can simplify certain troubleshooting tasks. For instance, measuring voltage between each phase and neutral can quickly identify a missing phase or unbalanced voltage conditions. The decision to include a neutral wire ultimately depends on a variety of factors, including the current and future load requirements, safety considerations, and local electrical codes. Consulting with a qualified electrical engineer or electrician can help to determine the best approach for a specific application. If the neutral wire is used to power control circuits, it must be sized to carry the maximum unbalanced load of those circuits. If the control circuits are relatively small, the neutral wire can be smaller than the phase conductors, but it must still be large enough to safely carry the current. Proper grounding is crucial for safety. All electrical equipment must be properly grounded to prevent electrical shock and fire hazards. The grounding system must be designed and installed according to the requirements of the NEC. If the equipment is located in a hazardous location, such as a wet or dusty environment, additional grounding requirements may apply. If the system is designed to supply sensitive electronic equipment, such as computers or medical devices, a dedicated grounding system may be required to minimize electrical noise and interference. The neutral wire can be used for testing purposes, such as checking voltage levels and performing continuity tests. It can also be used to help identify wiring errors. Testing should be performed by a qualified electrician using appropriate test equipment. The electrician should follow all safety precautions when testing electrical systems. Maintenance is essential for ensuring the safe and reliable operation of electrical systems. Regular maintenance tasks include tightening connections, cleaning equipment, and inspecting for damage. Maintenance should be performed by a qualified electrician. The electrician should follow all safety precautions when performing maintenance on electrical systems. The NEC is a comprehensive set of standards for electrical safety. It is updated every 3 years by the National Fire Protection Association, or NFPA. The NEC is widely adopted throughout the United States and is considered the authoritative source for electrical safety requirements. It is important to consult the latest edition of the NEC when designing, installing, or maintaining electrical systems. A qualified electrical engineer or electrician can help ensure that the system complies with the NEC and other applicable codes and standards. The size of the conductors depends on the ampacity of the circuit, which is determined by the load that the circuit will supply. The NEC provides tables that specify the minimum conductor size for different ampacities. The conductors must be sized to carry the full load current without overheating. The type of insulation on the conductors must be suitable for the operating temperature of the circuit. The conductors must be protected from physical damage. The conductors must be installed in accordance with the NEC and other applicable codes and standards. Overcurrent protection devices, such as circuit breakers and fuses, are used to protect electrical circuits from overloads and short circuits. These devices are designed to trip and interrupt the flow of current when the current exceeds a predetermined level. The size of the overcurrent protection device must be properly matched to the ampacity of the circuit. The overcurrent protection device must be installed in a readily accessible location. The overcurrent protection device must be tested periodically to ensure that it is functioning properly. The overcurrent protection device must comply with the NEC and other applicable codes and standards. Enclosures are used to protect electrical equipment from the environment. Enclosures are available in a variety of sizes and materials. The type of enclosure required depends on the environment in which the equipment will be installed. Enclosures must be weatherproof if they are installed outdoors. Enclosures must be dust tight if they are installed in a dusty environment. Enclosures must be explosion proof if they are installed in a hazardous location. Enclosures must comply with the NEC and other applicable codes and standards. Wiring methods refer to the way in which electrical conductors are installed. There are a variety of wiring methods available, including conduit, cable, and open wiring. The wiring method selected depends on the application and the environment. Conduit is a rigid or flexible tube used to protect electrical conductors. Cable is a factory assembly of two or more insulated conductors. Open wiring is a method of installing electrical conductors without any protection. The wiring method must comply with the NEC and other applicable codes and standards. Grounding electrodes are used to connect the electrical system to the earth. Grounding electrodes are typically made of copper or steel. The type of grounding electrode required depends on the soil conditions and the size of the electrical system. Grounding electrodes must be installed in accordance with the NEC and other applicable codes and standards. Bonding is the process of connecting all metal parts of the electrical system together to create a common ground potential. Bonding helps to prevent electrical shock and fire hazards. Bonding conductors are typically made of copper. Bonding conductors must be sized according to the NEC. Bonding conductors must be installed in accordance with the NEC and other applicable codes and standards. Electrical safety is of paramount importance. All electrical work should be performed by a qualified electrician. The electrician should follow all safety precautions when working on electrical systems. The electrician should use appropriate test equipment to verify that the electrical system is safe. The electrician should comply with the NEC and other applicable codes and standards. The electrician should be aware of the hazards associated with electricity. The electrician should be trained in the proper methods for working on electrical systems. The electrician should use appropriate personal protective equipment, or PPE, such as gloves, safety glasses, and arc flash suits. The electrician should never work on electrical systems while they are energized unless it is absolutely necessary. The electrician should always de-energize the electrical system before working on it. The electrician should look out and tag out the electrical system to prevent it from being accidentally energized. The electrician should test the electrical system to verify that it is de-energized. The electrician should be aware of the location of the nearest emergency shut-off switch. The electrician should know how to respond to an electrical emergency. The electrician should call for help immediately if there is an electrical emergency. In many cases it will not hurt anything, but can cause some confusion by other electricians that do not know the intentions of the previous electrician that pulled the wire. Make sure the wire is properly marked as unused on both sides.